We know gas molecules are far apart, move very fast in constant random motion, and have no attractive or repulsive forces between them. Let's take a look at liquids and solids. This table shows the criteria for describing a liquid. Compared to gas, liquid molecules are close together. Volume shape is the same. Density is higher. Gases are compressible, liquids are not. Imagine rubbing your hands, that's the motion of liquids. And intermolecular forces exist between liquid molecules. The liquid properties of viscosity and surface tension depend on intermolecular forces. Viscosity is the internal resistance to flow. Surface tension is the force within a liquid that acts parallel to the surface and tends to stretch the surface out. It's like standing in the middle of a trampoline. The surface stretches out. Oil has a higher viscosity than water. Stop the video and explain why. And here is the answer. Polar water has London forces, dipole-dipole forces, hydrogen bonds, whereas non-polar motor oil only has London forces. Although water has all three intermolecular forces, London forces are directly proportional to size. So the large motor oil molecules will have stronger intermolecular forces than the small water molecules. For this picture, think oil is not soluble in water, a prism, and light refraction. You had a lot of fun the last time you were in a slip and slide, but you want to slide better. Stop the video and figure, will acetone work better than water? And the answer is, look at structure, shape, polarity, intermolecular forces. Water has all three intermolecular forces, whereas acetone only has London forces and dipole-dipole forces. So water has stronger intermolecular forces and a higher viscosity than acetone. You probably did this when you were younger. You floated a bug on water, added soap, saw the bug sink, and drowned the bug. Stop the video and explain what's happening. And here is the answer. Water has a high surface tension because of the strong hydrogen bonds between water molecules. Add soap and soap can form hydrogen bonds to water. The network of hydrogen bonds between water molecules breaks and lowers the surface tension, and there goes the bug. Capillary reaction is the movement of liquid in thin tubes. Stop the video and explain why water creeps up the tube and has a concave meniscus, whereas mercury creeps down the tube and has a convex meniscus. And here is the answer. Water is more attracted to the glass than it is to itself, and creeps up the glass. Mercury is more attracted to itself than it is to the glass. That's why you see the convex meniscus. How does a paper towel wick water? Stop the video and explain this application of capillary action. And the answer is, the paper towel is designed to have tiny little tubes. Water is more attracted to the material than it is to itself, and capillary action. Here's another application of capillary action. How long should you dunk your cookie in milk before it falls apart? And here is the answer according to this rigorous study. In 2 seconds, 80% of the milk is absorbed. In 5 seconds, almost all the milk is absorbed. 8 seconds, cookie breaks. So the ideal is a 2 to 5 second dunk followed by a brief waiting period, then eat the cookie. The tallest tree at 370 feet was in Northern California. How does water get to the top of the tree to keep those leaves green? One way is by capillary action. If trees use hexane instead of water, would trees grow as high? Stop the video and answer that question. And the answer is, xylem are the thin vessels a few microns in diameter that transport water in trees. Polar water is attracted to the xylem through strong intermolecular forces. Non-polar hexane is not attracted to the xylem and will not travel very far up the trees due to those weak intermolecular forces. If you're of a certain age, you may have mixed or seen a bartender mix alcoholic drinks. But here's something strange. You mix a half a cup of ethanol plus a half a cup of water, and you will not get 1 cup of the mixed drink. Stop the video and use your knowledge of chemical forces to explain this observation. And the answer is hydrogen bonding. Ethanol and water hydrogen bond to each other and reduces the space between molecules. This reduces the volume, so the volumes don't add up. If you're a swimmer, did you know you can swim faster by spreading your fingers just a little bit so that a boundary layer forms between your fingers? This makes your hand more like a paddle so you can swim faster. Stop the video and use chemical force to explain what's happening. And the answer is hydrogen bonding again. The water between your wet fingers can form hydrogen bonds. The water molecules sticking together between your fingers form the paddle. And if you stay in the water long enough, your skin gets pruny. It turns out that water molecules gets in between these protein filaments and swells up.